So if you recall from this video is going to review solving by substitution. It will change a little bit. Some of it will be very similar to what you did in middle school. Some of it will be just a slight change to what you did in middle school. Solving systems is the learning target. We've already reviewed solving by graphing. We saw where there was one solution, no solution when there's parallel lines, or infinitely many solutions when all the points are on both lines because the equations give you the same line. Now, in solving by substitution, we're using an algebraic technique. We're doing algebra instead of graphing. And in doing so, just to review, if you get a number for x and a number for y that works for both equations, that is the one solution. If you are left with an equation that's not true and has no variables left, then that is the case of no solution. Your lines are actually parallel. They should have the same slope, but a different y-intercept. And if you get the case where your variables disappear in the solving process and you get the numbers to the equation to be a true equation, that's because your slopes are the same and your y-intercepts are the same, meaning that every point on one line is also a point on the other. So let's look at the process of solving by substitution. Some of this will be very basic, very similar to what you did in middle school. Some of it might change just slightly. The process of solving by substitution, at least in a two-variable system, the very first step is to, in one equation, get one variable. It doesn't matter whether it's the x or the y variable, whatever one looks easiest to use, by itself. So let's look at this. We'll go through the steps as we do these problems. For this first problem, I already have the y variable by itself, y equals 2x. So step one is already complete. The second step is to take what it is equal to its equal expression, which is on the other side of the equal sign, and plug it in, or substitute, plug it in, that's the substitution part, to that variable in the other equation. So in other words, instead of saying plug it in, substitute it in for that variable in the other equation. Well, where is that variable? That variable's right here. Here's my other equation. Instead of y, I should replace it with what y is equal to, 2x. And we should always do this in parentheses. Notice I have plug in parentheses, because sometimes there's a coefficient on this variable and we will actually have to multiply it by what's inside. So this is 2x. On the other side of this equation is x plus 5. So this equation was y equals x plus 5. We replaced the y with the 2x since y equals 2x. It's just like saying, hey, if y was the number 11, well, plug in 11 for y, and since you already know what y is, and solve for x. The only difference is we don't actually know the number for y right now. So now we're going to solve. So step 3 is to solve for the remaining variable. So I'm going to subtract x to move it over here. There was nothing to do with those parentheses anyhow. I now have x equals 5. Great, I've solved for one of my variables, but to solve the system I need to know the answer to both x and y. So the next step is to substitute that value in, or plug the answer to that variable into, now you should, if you're just trying to find the answer, you should be able to plug it into just one, but we're also going to need to check our answer, so we're going to plug the answer to that variable into both equations to solve for the remaining variable. So in this case, we found x first. We're trying to find y. Plug the answer to that variable into both equations to solve for the remaining variable. I have my answer for x, so I go back up here, y equals 2 times x, so I plug that in parentheses, and this equation, y equals x plus 5. Well, 5 plus 5 is 10, and 2 times 5 is 10. Since both of them gave me the same answer, I know that I have the right value for x, and now I have the right value for y. As an ordered pair, the solution is 5, 10. This would mean that if I were to graph these equations, they're in slope-intercept form, I would get an answer or an intersection point at 5, 10. The x value of 5, the y value of 10 makes both of these equations true. Let's take a look at example 2. For example 2, we have one equation in standard form. It would be easy to get that y variable by itself if I wanted to, but I don't need to because in the other equation, the y variable is already by itself. So step 1 is already completed for us. We do not need to get a variable by itself. Remember, this only has to happen in one equation. Since y equals x minus 4, I'm going to take that and plug it into the top equation. The top equation was 2x plus y equals 5. And substituting in for y the value of x minus 4. Now I always do this in parentheses. Luckily this was a plus sign. If it had been a minus, I would distribute that to both variables inside. If there had been a coefficient of 3 in front of the y, I would distribute that to both terms inside, not both variables, that's a variable, that's a constant. But I would distribute it to both terms inside. I don't have anything to multiply by this parenthesis or nothing to do to simplify it, so I can simply drop it. 2x plus x is 3x, so I have 3x minus 4 equals 5. To solve, I'm going to add 4 to both sides. 3x equals 9. Divide by 3, x equals 3. Now that I have the answer for the x variable, I'm going to plug it into both equations. My top equation was 2x plus y equals 5. My bottom equation was y equals x minus 4. In place of x, we're plugging in 3, or substituting in 3. 2 times 3 is 6, so this becomes 6 plus y equals 5. When you subtract 6 from both sides, you get y equals negative 1. For this one, y equals 3 minus 4, which is negative 1. Since they give me the same answer, I know that I solved for x correctly and that I have the correct y value. So our ordered pair is 3, negative 1. X is 3, y is negative 1. That point is the solution to both equations. I'm going to give you one more example before I ask you to try a problem. Actually, I'm going to ask you to try 2 problems before we do the next example. I'd like you to try number 3 and number 4. Number 3, there is already a variable by itself. In number 4, there is not a variable by itself, but one of them would be very easy to get by itself. Looking at problem number 4, top equation, there's a coefficient on x, coefficient on x and y. In the bottom equation, there's no coefficient on x, just on y. So simply by adding 4y to both sides to move it to the other side, we get that x equals 4y plus 11. These 2 equations are equivalent. So using this top equation and this one that we've just gotten the x by itself, you will try to use substitution. Please try number 3, we already have a variable by itself there, and number 4, where we just got a variable by itself, to see if you can get the correct solution. Please pause the video to do this. Welcome back. Please follow along. Hopefully this is what you did in your work and you can verify that you did it correctly. Since x equals the opposite of y minus 7, in the top equation we have 2 times x plus y equals negative 4. But in place of x we are substituting in the opposite of y minus 7. We do need to distribute the 2 in this case. This gives us negative 2y minus 14 plus y equals negative 4. By combining like terms, I have the opposite of y minus 14 equals negative 4. To solve for y, I first add 14, So the opposite of y equals 10. And then I divide by -1 or multiply by -1 to both sides. Y equals -10. You should have gotten the value of y to be -10. I will now take this and plug it into both the top and bottom equations. In the top, I have 2x plus y, I use parentheses for y, equals -4. In the bottom, I have x equals the opposite of y, -7. For y, I'm substituting in, or plugging in, -10. Here I have the opposite of -10, which is 10, minus 7, is 3, so I get x equals 3. Here I have 2x minus 10 equals -4, so I will add 10 to both sides. This gives me 2x equals 6. When I divide by 2, once again I get x equals 3, so I know that I have solved this system correctly. My ordered pair is 3, -10. The x-coordinate comes first, then the y-coordinate. So that is my solution for number 3. For number 4, we're going to look at that in just a second. Please try it if you have not already. In the next problem that you attempted, we're going to plug this in for x up here. So we have 4y minus 5 times x equals 9. Again, putting the x, what was the variable, in parentheses, plugging into it 4y plus 11, or substituting in the x equals 4y plus 11. In this one, we have to be careful. We need to distribute the -5, not just the number that's on it, but the sign as well. This gives us -20y minus 55, and then just bring down the 4y and the 9. 4y minus 20y is -16y minus 55 equals 9. We're going to add 55 to both sides. 9 and 55 is 64. When we divide by -16, we should get y equals, I believe, -4. Let me verify that. Yes, -4. So y equals -4. Assuming we did that correctly, when we plug it back into both the top two equations that we had, I'll probably just use this one because I know those are equivalent, we should be good. So 4 times -4, that's -16, minus 5x equals 9. I'm going to add 16 to both sides, -5x. When I add 16 to 9, I get 25. Divide by -5, x equals -5. So -5, -4. Now we have to make sure that that holds true for this as well. If y is -4, that makes this -16 plus 11, which is also x equals -5. So they are both true. Our ordered pair for our solution is -5. Always put the x-coordinate first, -4. It's not which variable we find first, but the x-coordinate that gets put first. Let me give you an example for number 5 before you try number 6. In this problem, I could easily get this variable by itself. Now, if they all had coefficients, maybe this was a, let me give you an example. Let's say this was a 2x minus 4y equals -8. It's not. But if it were, then I would simply try to get this one by itself because all of these are divisible by 2. Sometimes I may even have to include a fraction. Let's say it was, so if I did that, then I'd have to add the 4y first, and then divide everything by every single term by 2. X equals 2y minus 4. That's not this problem. I'm showing you if there was a coefficient on the y. Also, if there was a coefficient on the y, like, let's say, a -3y, well, you can choose then what you want to do, but since 2 goes into this, 3 doesn't go into either one, I would again try to get x by itself in this particular case by adding the 3y to both sides and dividing every single term by 2. It does leave you with a fraction coefficient on y, unfortunately, but hopefully it would work out in the system that you are solving. Some systems do have fractional answers though, so be prepared for that. In this particular example that's given, though, there is no coefficient on the y. Well, there is. It's a -1. So you have your choice here. Obviously, I wouldn't want to get anything by itself. If I have an easier one to get by itself in the top equation, I'm not going to target the bottom. I'm going to add y to this side and then add 8 to this side. So 2x plus 8 equals y, because I added y to this side and added 8 to the other. I'm going to take this and plug it in for y. 3x plus 2 times y equals 9. Our expression for y was 2x plus 8. We're going to distribute the positive 2 to both terms. So 4x plus 16, bring down our 9 and bring down our 3x. This gives us 7x plus 16 equals 9. When I subtract 16 from both sides, I get negative 7. Positive 7x equals negative 7. Dividing by 7, I get x equals negative 1. When x is negative 1, we're going to plug that into both equations. 2 times negative 1 minus y equals negative 8, and 3 times negative 1 plus 2y equals 9. Here, that's negative 2 minus y equals negative 8. I'm going to add 2 to both sides. Opposite of y equals negative 6, so y equals 6. In this equation, we have negative 3 plus 2y equals 9, so I'm going to add 3 to both sides. 2y equals 12. Divide by 2, y equals 6. Since it's 6 for both of those, our final solution is negative 1, 6. Please take a moment to pause the video and try number 6. There is a variable that should be easiest to get by itself. Welcome back. In the top equation, hopefully you got y by itself by subtracting 2x from both sides, giving you negative 2x plus 14, or 14 minus 2x. Substituting that into the bottom equation, you would have plugged that in, the negative 2x plus 14, or 14 minus 2x, and you would have distributed the positive 4, giving you negative 8x plus 56. Bringing down your negative 10, bringing down your negative 3x. This gives us negative 11x plus 56 equals negative 10. Subtracting 56 from both sides, negative 11x equals negative 66. Dividing by negative 11, x equals 6. We take that value and plug it into both equations. I'm going to need a separate sheet of paper to do that because I wrote too large and ran out of room. So here I have 2 times 6 plus y equals 14. Here I have negative 3 times 6 plus 4y equals negative 10. This becomes 12 plus y equals 14. When I subtract 12 from both sides, I get y equals 2. This becomes negative 18 plus 14y equals 10. When I add 18 to both sides, I get 14y equals 28. Dividing by 14 to undo the multiplication of 14, I get y equals 2. So since y is 2 for both of those, x must be 6, and that must be the y that goes with it. My solution for number 6 is 6, the x-coordinate, 2, the y-coordinate. This concludes the video examples for solving by substitutions and the try-it problems that go with the notes. Please work on the ones that are required in your summer packet. If you'd like to see additional examples, you can look for YouTube videos or email me to get access to an online textbook. Enjoy the rest of your summer. See you soon.